Hello everyone. This is a midterm case study on our topic electric scooter company. Myself, Ankitan, and my group members are Tomendra, Niket, and Priyam. A short introduction about what we did. This presentation is a solution on the midterm case study focused on revamping an electric scooter and its companion mobile app. We were tasked with answering 8 questions covering product features, and its security, testing, launch strategy, AI integration, and more, all aimed at improving performance, user experience, and market competitiveness. Let's walk through each of the questions and our proposed solutions. The first question, where we have the must have features for our scooter app. Let's start by exploring the ideal app for our electric scooter that should offer. Our goal here was to combine the needs of safety and usability with smart integration into the design of the app. After researching user behavior, market leaders, and the company's issues faced by the older app version, we shortlisted 10 essential features, out of which the top 5 are considered non negotiable for delivering a user centric experience. Going to the first one, detailed battery monitoring. It has real time status such as battery percentage, voltage, temperature, and estimated range. Also, the riders will receive alerts when battery health degrades or if a potential overheating situation is detected. The second one, smart charging schedules. It helps us suggest off-peak charging times based on users' ride frequency and charging habits. This extends the battery life and saves energy costs. Third top, integrated turn-by-turn navigation. Google Map integration optimized for EVs with safe routes, hazard alerts, and voice prompts, helping rider avoid steep slopes or long detours that could affect range. Number fourth, one touch emergency assistance. One tap access to emergency contacts, which are preset, and GPS based location sharing, and even accident detection using onboard sensors. Fifth topic, which is intuitive user interface, a clean, customizable dashboard that shows essential metrics and supports accessibility features for like font scaling or dark mode. And we have some other additional features which includes OTA updates, firmware updates, document storage, ride analytics, push notifications, feedbacks are considered useful but ranked lower. Moving on to our second question, which consists of some of the design considerations that we have for designing our storage features. So, our document storage architecture goes like design objectives, which include categorized uploads by document type, might be RC, license, insurance, metadata tagging, example, expiry date, document type, driver name for quick retrieval, syncs across phone and tablet, view, edit, remove option with confirmation dialogues, offline actions with local caching, and security considerations include AES 256 encryption for data at rest and at transit, basically for storage and transfer, role based access, user only or shared with authorized personnel, multi factor authentication for document access, secure API gateway with token authentication, scheduled cloud backups with retention policy, and regular security audits and penetration tests. The architecture flows like app, API gateway, encrypted cloud buckets, and tablet sync. So basically, we have a modern and secure document vault that helps us users stay compliant, safe, and confident during checks or emergencies.
I am Priyam Rai. So now I am going to speak on this testing charge and sync issues part. So we have picked two common complaints about users that have been raised, and that is the scooter takes longer to charge over time, and the app doesn't always show accurate or updated information. Let's start with the charging issue. Over time, batteries naturally degrade, but software calibration problems or extreme weather can make things worse. So, to really get to the root of the issue, we are going to simulate our more than 100 charge discharge cycles and measure how the charge time changes. We will also run tests under different temperature conditions, hot, cold, and even humid conditions, and compare results using various chargers. The second issue that has been faced is that the outdated data in the app, like when the ride is over, but the app still shows old stats. That's usually due to syncing delays or weak network connections. So our test plan includes forcing the app to sync under 2G, 3G, and 4G and 5G, and even Wi-Fi, and the timing, how long it takes to refresh the data. We'll also track the last update timestamps between the vehicle and the app to spot any lag. With these test cases, our goal is to recreate the real-world frustration users are facing and fix them before the next release. Now, the second part is the launch strategy inside out and outside in. Talk about the launch plan and how we are making sure it's not just technically ready, but also well received by the users. We used a combination of two approaches here, inside out and outside in. Inside out is all about getting things right internally. That means our QA team tests every feature across multiple devices and OS versions. The support team is trained with FAQs and help content, and the servers are prepared to handle thousands of requests. Before launch, we do a dry run or pilot phase with our own employees just to catch any last minute bugs. On the other hand, outside in is where we really involve the users. We send out pre-launch surveys to understand what they expect. A small group of loyal users is invited for beta testing, and you use their feedbacks to improve before the big day. We also prepare our App Store listings, screenshots, and onboard guides to make a great first impression. And of course, we build excitement through social media teasers, campus events, and partnerships. So while the inside out part keeps things stable, the outside in part keeps it relatable and user focused. That balance is what turns a launch into success story.
I am Niket Patel and I'll be moving on from here. Coming on to the next question, which is prioritizing features. Every feature sounds good on paper, but with limited resources, we had to prioritize. We've split features into two groups, P1 and P2. P1 for must-haves and P2 for important but not urgent. Then we rank them from 1 to 10 based on the user value, technical effort, and how much they improve the riding experience. So at the top, we've got battery monitoring because nobody wants surprises mid-track. Smart charging alerts to improve battery life and cost efficiency. Navigation so users don't have to switch to Google Maps. Emergency assistance, literal lifesaver. User interface design because even the best feature is useless if the app is hard to use. After that come the P2s, OTA updates, document uploads, ride analytics, and notifications. These are all great, but we can launch them without them initially and add them via updates. This kind of structured prioritization helps the engineering team stay focused and ensures that the features with the biggest impact are developed first. Moving on to the next question, which is cloud performance and improvements. Our next focus is cloud performance, which is where a lot of issues tend to sneak in. Right now, the app suffers from three major problems: slow loading times, infrequent data updates, and occasional crashes during high usage. So, how do we fix it? We start by switching to a serverless backend like AWS. This means the system automatically scales depending on how many users are online. So, no more crashes when everyone logs in at once. Then, for real-time updates, instead of a traditional HTTP polling, we implement MQTT or WebSocket protocols, which push updates instantly without overloading the server. To speed things even more, we cache commonly accessed data using a content delivery network or CDN, which brings data physically closer to the user. And finally, we group and schedule backend writes in batches. This reduces database stress and increases with overall performance. What this means for user is simple: faster app load times, real-time sync with the scooter, and no annoying lag during peak hours.
Myself, Domendra Kumar Chandravanshi. Uh, AIML use cases. Let's make the scooter smart. Collected data, GPS, elevation, and riding style. Second, battery health matrices. Third, error logs and wear indicators. Second one, email powered features, predictive maintenance alerts, eco store with gamified tips, smart charging suggestion, dynamic routing based on range and terrain. All analysis happens in the cloud with models retrained regularly to improve accuracy. Takeaway: intelligence adds a proactive, personalized layer to the right experience. Question number 8, product mind map. Here's our vision for the next generation vehicle. Goals: second in market share in 1 year, 10% profit margin, zero major bugs in first 3 months. Key features: carbon fiber body, fast charging, 0 to 80% in 30 minutes. Tablet dashboard with maps and controls. UX and UI upgrades, gesture-based controls, visual battery prediction, poster-ride eco performance reports, technology stack, AIML models, cloud sync, Flutter-based cross-platform app. Takeaway: it's not just a scooter, it's an intelligent, connected user-first ecosystem.